Now let me read the problem for number 4. We need to determine the volume of an ellipse that is x squared plus 3y squared minus x equal to 1 revolve about y is equal to 3. So you can always try to draw the figure, and you can manually draw it, or you can use, let's say, application. And in today's video, I'll be using GeoGebra to plot this para lang mas maging accurate, or makita nyo ng talagang accurate yung figure. So this is what it looks like when you graph this x squared plus 3y squared minus x equal to 1. This is your ellipse. The principal axis is along the x-axis, and this is the axis of revolution. So if you try to like revolve this about this certain y is equal to 3, so ito yon, y is equal to 3, and this is your ellipse. So revolve natin dito, mami-mirror lang dyan yung figure, something like this, and then you can form something like a torus, pero syempre ellipse yung kanyang area and that. So that's what it will look like, pero syempre we need to determine yung points dito, okay? If you want to use, of course, kung gagamit tayo ng vertical strip, okay? So in this solution, I'll be using the vertical strip so that we are perpendicular with the axis of revolution. So from this, kailangan nating gamitin yung knowledge natin sa analytic geometry. So we could start by having the original equation, that's x squared plus 3y squared minus x equal to 1. And then I'll try to complete the square for x, so that's x squared minus x plus 1 over 4. And then plus 3y squared is equal to 1 plus 1/4. And then we can have x minus 1/2 squared, okay? And then plus 3y squared is equal to, that's 1 plus 1/4, so we have 5 over 4. And then we could divide this by 5 over 4, each of them, yung term, para makuha natin yung kanyang standard form. So from this, we could get, ayan, so ito na yung for our sa x natin, and then for y, we could have y squared divided by, so this is actually 12 over 5, so I'll be using 5 over 12 dito sa ating denominator, and then this is equal to 1. So remember, this is your standard form of the ellipse, so we could say that the center is on 1/2, 0, so ito yun, somewhere here, kasi this is 2a. So half, this is 1, so technically this should be 1/2, okay? But the point that I need here is actually this point, which is actually obtained from the center going to this distance, so that is actually your a. Okay, remember that is the distance from the semi-major axis, we call that. So therefore we could just pick out the larger value here and then take the square root of that, and that will be your value of a. So from this, I could have a is equal to the square root of 5 over 4, which is also equal to the square root of 5 over 2. And then so to determine the values of this point, let's call this, let's say this is your x sub 1 and this is your x sub 2. So your x sub 1 is simply the value of the center, or the x value of the center, minus this a. So what is the value of your center? From this particular equation, we could see that the center is at 1/2, 0. So therefore that is 1/2 minus square root of 5 over 2, and the other one is 1/2 plus square root of 5 over 2. So you can write this as 1 minus square root of 5 over 2, and then square root of 5 plus 1 over 2. So these are your two values that we'll be using in this procedure, or in this problem solving. So therefore, if the element here is vertical and it is perpendicular with our axis of revolution at y is equal to 3, then we could use the formula v is equal to pi from a to b, and then we could have the r of x, okay, squared dx. But because there is kind of a hole, not really a hole, but a space from the axis of revolution going to that portion of the curve, so we could say that it's not enough na ito lang yung ating equation, we also have to remember na this is a washer. So you could use r of x squared and then minus r of x squared, which is denoting the outer radius and then the inner radius from the axis of revolution. So I will be solving this in two ways. So unahin natin yung, or probably three ways. Unahin natin itong general concept ng washer method, and then let's check this using the theorem of Pappus as well. So if we start with the outer radius, we could see, so ganito yung gagawin natin, no? Whenever you have the axis of revolution, you'll be referencing your point of view dun sa inyong axis of revolution, and then whatever is the curve that is at the farthest from the axis of revolution, that will be your outer radius. So looking from the point of reference of the axis of revolution, what could be your outer radius? So the outer radius is actually this curve around here. And how could you represent that? So starting from the point of or the axis of revolution, that is 3 units from the x-axis, so you could always say that there are 3 units from this point going to that certain x-axis. So from this point onwards, you would have to add that certain part of the ellipse, which is actually y in terms of y in terms of x. So it's like 3 plus whatever is this equation of the ellipse. So the inner radius is, so you start again from the axis of revolution, and then you try to draw a line, and then the innermost part of the curve would be your inner radius. That's why this is that part of the ellipse. So it is still the same ellipse, it's just that yung part na mas malapit yung tinitake natin for the inner radius. So how do we represent that in terms of the equation? So yung ating r of x in this case, so your r of x is of course 3 units from the axis of revolution, so that's 3 plus the equation of the ellipse. So how do we represent the equation of the ellipse? So coming from this x squared plus 3y squared minus x is equal to 1, we need to represent this in terms of something like y is equal to x, something like that. So if you want to utilize this idea, so we have 3y squared is equal to 1 plus x minus x squared, and then dividing this all by 3, and then square rooting, is there a word like that, taking the root of this, so we have y is equal to plus or minus the square root of 1 plus x minus x squared all over 3. So in this case, there are two it is separated by plus and minus, because the positive one is this portion of the graph, and then the negative one is the lower portion. But do we still have to incorporate the signs when we use this kind of disk method? So the answer is not necessarily. So you could just use the positive one, because we already have this distance taken from the x-axis, so it's like 3 plus whatever is the equation on the positive value. Kasi if ever you'll be using the negative here and then the positive for this case, the equation will just cancel out, so you won't be able to determine the volume correctly. So what I'm suggesting is that if you have some kind of distance from a certain axis of revolution, you just have to add the equation of a certain function wherein you have positive or negative combination of that. So you just take the positive value, and then but make sure you have to add this 3 if it's the outer radius, and then subtract this equation from 3 if it's the inner radius. So ano ba yung sabihin ko? So for r of x, you could say that this is 3 units, so meron 3 na agad dyan, paplasan mo ngayon nung equation of the ellipse, so that's just copy the ellipse equation, so that's square root of 1 plus x minus x squared over 3. Okay, so it is always necessary that this is just y, so y lang yan, and then this is in terms of pure function of x. And then how about the inner radius? So you have r of x, and then so diba this is 3 units, but you have to subtract this, so you could say that 3 minus, remember it's always the farthest portion minus the innermost portion, so lagi tayong ganun. So that's 3 minus whatever is the equation. So we have the same equation for, so the square root of 1 plus x minus x squared divided by 3. Okay, and you can plug in all of these values to our equation. So that's v is equal to pi. We evaluate this from x sub 1 to x sub 2 because we can freely draw any vertical strip, and we're just having the upper portion of the curve and its lower portion in terms of the positive and negative side of it. So we have square root, 1 minus square root of 5 over 2 all over 2, and then 1 plus square root of 5 all over 2. And then what's your r of x? The outer radius is 3 plus square root of 1 plus x minus x squared all over 3. And then you square this. You can just, gamitin ko na lang is yung parentheses. Okay? Then minus 3 minus square root of 1 plus x minus x squared all over 3 squared, and then dx. Okay? So, sabi ko nga before, I'm allowing you to utilize your calculator to integrate this. So you could just use your calculator, type this whole term. So I'll be doing it here. So hopefully ay ma-integrate niya ng mabilis. Because I think this one is medyo matagal siyang solvent. Whenever you're finding it hard to understand yung concept ng itong mga principal axis and then yung mga pag-standard formatting ellipse, so you might want to review your analytic geometry kasi this one is actually not part of hindi na siya part ng ating discussion sa calculus. So parang we're hoping na you already know that from your high school subjects. So it is very important that you use or you utilize this parentheses kasi this is what makes these things complicated. Kasi kung hindi nyo alam yung tamang gamit nun, then baka magkamali kayo lang. Laging syntax error lalabas dyan. So, you have to make sure na you're really using this correctly. Okay, matakot maglagay ng parentheses kasi mas okay yun eh. Okay, so I think we're done with the writing. So we can just press equals. Okay. And mind you, this takes quite a long time kasi this one is integration and the calculator is having the square root and then yung limits pa natin is naka-radical. So if ayun pala, okay na. So that's 13.6034. So that's 13.6034 pero hindi pa naka-multiply yung pi. So multiply ko ngayon yung pi. Okay? So this gives me 42.7366. Okay, so that's 42.7366. So cubic units. I used to write square units sa ibang solving. So may correct na lang nun. Okay, so this is the first solution that I want to present using your concept of integration by washer method under the disk method. Now what if we try to solve for this using another method? Let's say we apply the same concept or the theorem of Pappus to solve for the volume of this ellipse. So let me just, I think I'll be needing this still, so and probably this one. So let me just remove this part. Okay, so I'll be leaving the correct answer so that we have some reference for the answer. And I don't think we still need this. Kaya ba natin to? We don't need this anymore, so yeah. Okay, so going back to the idea of Pappus, we could say that the volume is 2 pi, and then that is your area, and then of course the geometrical centroid. So the geometrical centroid is the distance from the axis of revolution going to the centroid of your figure or the surface. So in this case, if we know quite well that the center lies at 1/2 0, so the distance from this center, that's 1/2 0, is just simply the difference between the value of y and then the value of y of your center. So that's something like 3 minus 0, and that is 3. So therefore, from our just by looking at the figure or just by inspection, we could say that x bar is equal to 3. So that's the geometrical centroid in this case. So we don't have any problem with that. But we need to find the area, and the area of ellipse is given by pi times AB, wherein A and B are the semi-major axis and semi-minor axis respectively. So we could say that this is pi. We multiply this by A, that's square root of 5 over 2. But how about our B? So we need to determine our B, but again, if you have an ellipse, your B, this is the something like x squared over a squared plus y squared over b squared. So therefore, this is your b squared. Therefore, if you want to find b, you could just take the root of this 5 over 12. So that's square root of 5 over 12, and that's your b. So we could have square root of 5 over 12, and then and that's it. That's the area of our ellipse. So the answer for this particular area would be 5 square root of 3 over 12 pi. That's square units. Okay, so therefore the volume of this the volume of this ellipse rotated at y is equal to 3 would be the volume equal to 2 pi times the area. So that's 5 square root of 3 over 12 pi, and then you multiply this by the geometrical centroid, so that's 3 units. So we could have the cubic units as our final unit. So we could just multiply by 3 and then times 2 pi squared. So the answer is still 42.7366 cubic units. So this one is a very easy problem to solve when we utilize the theorem of Pappus. But this is easy because we could determine easily the centroid of an ellipse. That's typically the center of it. And the distance from the axis of revolution is very easy to determine because the center lies at the x-axis. So you just have to take the distance itself of the axis of revolution from the x-axis, and that would be your geometrical centroid. But what if your curve is an irregularly shaped figure? Or what if it's not square or an ellipse or a rectangle or a triangle? So it's quite difficult for us to determine the centroid of that particular figure because it takes quite a while to understand the figure itself first, and then you just have to use another method of actually it's a calculus still to determine the centroid of that particular figure. So this theorem of Pappus is only recommended when you're certain that you can find the area and the correct centroid of the surface or the figure or the area itself. But if it's not possible for you to determine the area, or not really the area but the centroid of that area because it's irregularly shaped or not a really a regular polygon. For example, you have this kind of figure. So can you really determine the center of that? You know quite well that it's around here, but can you really determine the coordinates of that by just probably inspection or probably inspection. So it's quite difficult for you to do that because it's irregularly shaped. So this theorem of Pappus is not recommended in that certain kind of scenarios. So that's usually happens. So that usually happens when we encounter areas between two curves, and the curve is not. The curves are not actually really flat. So, yeah, I would still suggest that you have to use your general formula rather than using theorem of Pappus when it comes to situation like this. Okay, and then the third solution I think would be utilizing the horizontal strip. So I can now remove siguro this one, and let's just leave this from the previous answer para reference ulit natin. Okay, so using the horizontal strip, you could always draw this portion, and diba, if you would just take this horizontal strip, you could see it from here. Now this is your dy. this is the distance from that certain curve going to this curve. So you need to find the x values in terms of y. So that's the difference between these two. So you could just say that this is your delta x, okay? And then that's it for your horizontal strip. So this horizontal strip is actually parallel to the axis of revolution. So if you would be utilizing that, we know quite well that we need to use the formula for the shell method, which is the volume is equal to 2 pi evaluated from C to D, and we could say that we have P of y, and then let's say we have G of y, and then dy. So how do we continue this by determining our equation? Now going back to this delta x, we know that this is that portion of the ellipse, and the endpoint is the closing part of that certain ellipse. So we need to express this so in terms of x, in terms of y rather than x, because that's the equation that we need. So going back to our equation, we could see that we have this one. So we could rewrite that in terms of x is equal to where can you write it? So dito na lang siguro, since di naman natin gagamitin to. So we could have x minus 1/2 quantity squared, that is equal to 5 over 4, then minus 3y squared. And then we take the root of this equation, so we have x is equal to the plus minus square root of 5 over 4 minus 3y squared plus 1/2. So this is your equation of your x. So pag right, that is positive, pag left, that's negative. So the formula we'll be using the shell method would be 2 pi. This is already the equation. So kung hanapin natin yung delta x, so let's say yung g of y mo is yung delta x. So that is the positive side of that ellipse minus the negative side of that ellipse. So therefore, your g of y is equal to the positive portion, so that's square root of 5 over 4 minus 3y squared plus 1/2. And then you subtract the negative part, so that's minus negative 5 over 4, minus negative, saan ba yan? Minus negative square root of 5 over 4 minus 3y squared plus 1/2. Okay, so g of y, we could see that this will cancel out, and then itong positive minus negative would be added, so we could have 2 and then the square root of 5 over 4 minus 3y squared. Now these 2 times the equation of the curve, this is always, not really always, but often encountered in shell method. So you have to expect na kapag yung ating figure is separated by the plus minus, not really separated but parang divided siya by plus minus na portion ng curve, kasi circular sila. So you have to expect na magkakaroon ka ng twice nun kapag hindi ginagamit natin ang shell. Usually ganun yung nangyayari. Pero syempre, that is only applicable kung may plus minus yung equation mo, no? And then you're taking literally the length of that certain vertical strip, horizontal strip, with the endpoints on the curve of the figure itself. So with this, we already have the gy. Now, how about our p of y? So again, p of y is the distance from the axis of revolution going to your strip. So you might be thinking, so if this is the distance from this certain portion, if the horizontal strip is drawn before this 3 units, and this is literally your value of y, we could say that your p of y is, of course, 3 minus y, because that's how it is viewed from the fact that this is 3 units and then this is just y. Now how about if your horizontal strip is drawn somewhere below the x-axis? So that means that this is 3 units, and then you could have here your y, you could have a plus y. So in this case, that's 3 plus y. So what is really the correct equation? And what if your your axis of or your horizontal strip is literally drawn at the very x-axis. So, gulo na natin ano. So, what if it's drawn along that? So, in that case, your P of y would be 3. Now, let's try using all of this and then let's see what happens when we try to incorporate all of the possible combinations of your P of y. So, I can also go to delete this kasi hindi naman tayo gumagamit ito. Ayan. So, with this, let's plug in all this stuff. We have v is equal to 2 pi, and then what will be the limits and then from c to d. So, we go back to this b, that is square root of 5 over 12, and we know quite well that this portion here, which is your c, is the negative square root of 5 over 12, and then this d is your upper limit, that's positive square root of 5 over 12. So we have negative square root of 5 over 12, and your upper limit is square root of 5 over 12, and then your g of y is 2 square root of 5 over 4 minus 3y squared. We multiply this. Now let's have 3 minus y first and then dy. So therefore the volume, let's use the calculator to solve for the volume. Okay, so okay, we have 2 pi. So, isulat na natin yung 2 pi para diretso na tayo, hindi tayo multiply later. So, we have 2 pi, and then that's negative square root of 5 over 12. And then square root of 5 over 12. And then 2 square root of 5 over 4. So, again, ginawa natin is in-express naman natin siya in terms of y rather than x kasi our strip, horizontal strip, is actually parallel to the axis of revolution. So you multiply this by, so it is always better to use parenthesis na lang dito kasi very prone to error yung multiplication symbol natin. So we have 3 minus y. Okay, so let's try looking at this and let's see if the equation gives us the same answer as the volume of 42.7366. Okay, that's it. So the volume is 42.7366 cubic units. So using our horizontal strip, we were able to obtain the same results. Now, sabi ko nga, what if tama yun if your horizontal strip is drawn above the x-axis, but how about if it's drawn at the lower portion of your x-axis? So this equation is still the same, but the portion 3 minus y would be changed to 3 plus x. Okay, so let's try doing this and let's see the result if we can still obtain the same result. Kasi diba, we could draw a lot of different horizontal strips by just looking at the graph here. So that's still the same. Okay, and lastly, we try having yung ano na lang, distance niya directly from the x-axis going to the geometrical centroid. So that's 3 units lang. So diba yun yung distance niya from the center. So ito yun. Okay, so what? Okay, that's 42.736. So, nakita nyo dyan na even if you have a lot of varying distances from the axis of revolution going to your horizontal strip, that doesn't matter anyway kasi you will still obtain the same volume. Even if you have the exact distance from the centroid going to the geometrical geometrical centroid going to the axis of revolution, so you will still get the same results. So, what is the conclusion to this? When you have a vertical horizontal strip and the axis of revolution is just parallel to that, so you'll be using the shell method, and whenever the shell method is utilized where you have a certain distance from the geometrical centroid to the axis of revolution, the distance doesn't matter anyway. So you just have to incorporate, hindi lang siya y, kailangan incorporate mo yung distance. Let's say 3, so you could just use 3 plus that y, 3 minus y, or even y minus 3, that's still okay. Magbabago lang yung sign. Or you could just use yung very distance siya from the centroid, so that's just 3 units. And the difference between this horizontal method, ay, horizontal strip to the vertical strip, or the shell method to the disk method, is that sa disk method kasi that's perpendicular. So, ang accounted natin na distance from this is coming from the vertical strip itself. Kaya we utilized yung ating idea na 3 plus that function with this expressed into x, and then 3 minus that certain function expressed to x. Doon natin in-account ngayon yung 3 units from the axis of revolution. So, ayan, hopefully ay nag-gets siya kasi this topic is quite complicated talaga, and I want to conduct an online class to this rather than video kasi well, literally it's difficult, and it's more difficult if you can't ask questions to the professor. But I think we could just continue muna, and then let's see what happens next.